All right. Hello, everyone. Welcome back. So this is the second lecture of the second week. Got a decent amount of stuff up on our whiteboard. Like I said, we're going to have a few more notes in the beginning. And you know what, honestly, we're going to have a decent amount of notes sporadically on this because we'll be talking about the project at some point, talking about the midterm at some point, blah, blah, blah. So it's usually full of lots of things, not just always due dates. Okay, so let's break this down into segments. We will have finished all of chapter 1 by the end of today. We're also going to get a little into chapter 2. So that means that 1.1, 1.2, and 1.3 all have due dates. 1.1 due on the 8th. We talked about that last time. And I'm not going to put the by 11:59 p.m. part anymore on these assignments. After 2 weeks, you should be used to that aspect. It will always be 11:59 p.m. unless I say otherwise, which I don't ever anticipate doing. So 1.2, 1.3, I mean, we practically finished 1.2 last time, but I'm just lumping it in with today's, so doing a week. So those are due on the 10th. Another friendly reminder to read ahead, and I will not always give these reminders. This should just become programmed in your QR Math 154 brains sooner than later. You are always responsible for reading ahead. I don't always get to go through as much material as I would like or as slowly as I would like. There just aren't enough hours in the day or this course. So you should start reading ahead into chapter 2, 2.1, 2.2, maybe even 2.3 if you have that kind of time, but at least get to 2.2 before next class. And if you can't put your eyes on the e-text, definitely put your eyes on the notes to share file. I would say that's first priority, and then e-text probably second priority. Another reminder, and you'll see these for a little bit as well, practice with Excel over and over and over. Don't just do a homework, make an A or a B on it and walk away. Do it again. Do the stuff that I do in class and do it again. Become proficient and efficient with this. You will hear me talk about, or you will have heard me talk about making an addition or multiplication table last time and this time. So that is going to help you for the 1.8 Excel file, which will be our third one. So we have one more after the heart rate, then the thing that this multiplication table that you'll see me do. That will be very, very helpful. This chapter 0 spreadsheets are due today by midnight. I've had a lot of people emailing me about this one. And remember, you're just making what we did in class. There's nothing crazy about it. You have a full video of me detailing every little thing we did. So hopefully that should not be an issue. Remember, you do it, you get a 100. You don't do it, you get a 0. And that's it. You're submitting that in Canvas. It's one of 2 files you'll submit in Canvas that's an Excel file throughout the semester, the second being the project. The rest of them are just straight up in my math lab. So your first traditional Excel homework, the heart rate file 1.1, that's due on the 8th. Spoilers, the second one will be 1.3. And as I mentioned last time in class, the 1.3 Excel file is going to be very similar to that TV loan Excel file we built together. In fact, it is a TV loan problem, but there's a different aspect to it, and I don't want to spoil too much. We assigned a discussion board last time, and that was called Week 2, Lecture 1. Remember, you were only answering one question, just one question, just one question, not one question per page, not one question per number, just one question. That way we give as many opportunities to other students. Because if you've answered question 5A and 5B, and then someone else comes in and answers 5B, I can't give them credit because they already see the answer if they say the same thing as you. So the second discussion board that we'll be assigning is going to be called Week 2, Lecture 2. You can see I just named them based on when they were given, and that'll be due on the 10th. Now, in the fall and spring, I usually just give one class to do discussion boards. I'm starting this out with a full week since I know we're getting a lot thrown at us with the 50% acceleration being summer. So for now, I'm giving you a week on these discussion boards, but I do not anticipate that I'll do that all semester. So please be aware that once we get used to things, there's a good chance I'm going to start making the discussion boards due next class, which is much more traditional. And again, that's because these are super easy. You just go in and answer the next question that's available. So if someone answered question 6 and 7's next, then you answer 7. It's 5 to 10 minutes of your time, and you still get credit even if it's wrong. And if you're wrong, then that gives someone else an opportunity to come in and say, hey, I think Bob did this wrong. Here's what I have. And then even more people can have discussion opportunities. So even though there might only be 10 questions, there's still a possibility for 12, 13, 15 students to actually be awarded credit for that one. And also remember that, let's say there's 10 questions, 10 students have answered it, they're all perfect, no one can conjecture otherwise. If you're thinking you're not going to get credit, don't worry about that. Just make sure to answer the next discussion board. Again, especially in the beginning, not every student's going to have opportunities, but once we get into some more open-ended types of deals, types of problems, I'll be able to say, all right, well, everyone has an opportunity, just do the next increment, just do the next year, whatever. So those are when you absolutely must answer one. But for now, when there's only, say, 10 or 15 opportunities and 20 to 24 students, if you miss one, just absolutely make sure you do the next one. If you miss 2 in a row, then you're going to be punished double for that because you clearly are not participating. And it surprises me how many people don't want to participate in these discussion boards. This is an easy 10% of your grade. This is the difference. If you make all A's on everything, but I see you haven't done discussion boards, you're going to B. If you made all C's on everything and you haven't done a discussion board, you're getting a D. You don't want that to happen. Easy, easy, easy credit. I love this course and how much of the grade is homework because so many math students feel like they have things down, they do all the homework, and then they struggle with the test. And A's on homeworks turn into C's on test. Well, this course, only 40% of the grade is test, unlike a normal math course where 80% of the grade is tests. So this is giving you an excellent opportunity to have your grade boosted just by effort throughout the semester. So please don't slack on the homework. Please, please, please remember that you're responsible for investing a lot of time in this. As we said, 9 or more hours per week should be going into this course alone, unless you're able to get A's by doing 7 hours or A's by doing 6 hours. If you do 9 hours and that's not enough for you, you're still making D's and C's and you want to make better grades, then put in 10, 11 hours, 12 hours, whatever. Time invested is going to be critical for this course. If you are an MDE 54 student, which as far as I know, no one has emailed me that they are, so this will be a reminder, if you are an MDE 54 student, to please email me and let me know who your instructor is. That also means you're supposed to be spending twice as much time this summer working on your math. That's 18 hours or more a week, because that's also a math course. It's also 3 credits, which means also 9 hours outside of class in a summer semester. Again, I'm not trying to terrify you or scare you. I'm trying to remind you of what's expected because we want you to do well, and the invested time is critical for that. I know I'm repeating myself. I do that a lot, but I think it's important. Especially when I go through classes and read emails and stuff, and it's a reminder that I have to repeat myself. But anyways, we're going to pick up where we left off talking about Excel versus math type. And what I mean by type is how a problem can look in Excel versus how it looks when you just write it traditional math, like that 3 plus 4 over 12 or whatever that fraction might have been. So we would have had something like, my pen's not working, so it's a good thing I have the video prepared because that would have been a problem. Sometimes that happens. All right, so if you just had 3 plus 4 and then all over, so the 3 and the 4 in the top of a fraction, all over, let's say a 12, in Excel, you would have to, instead of just writing 3 plus 4 slash 12, you would have to have wrapped the 3 plus 4 in parentheses to signal that it was the top of a fraction. That's the only way Excel would know. And there's a lot of other technology out there that has similar issues. And we saw that last time. You're going to see that on the screen in just a second, so I don't feel too terrible about the pen. But let's go ahead and get back into it. And then we will start talking about this second discussion board, the one for week 2, lecture 2 that's due in a week, which we had already kind of alluded to previously. It's got 3 different pages worth of problems, and I don't want to leave that on the screen too long because you're going to see it very short. All right.
So let's take this idea and go with it to page 37. Page 37. 37. Here we go. Now let's do this. Actually, I don't want it on the same document. Go. All right, so guided activity number 1, page 37. Try and follow along with this. For each of the following, compute using proper order of operations. So some of these I'm going to save, some of these I won't. It's these top ones that I am going to let y'all do, but it's the number 2, A, B, C. I thought there was a D for some reason. Nope, just an A, B, and C. So we're going to do these. I'm going to leave these for y'all. So for number 1, A through E, A through E. This will be part of your discussion board. 9-8. So 1 student each initially. Remember, if someone does it wrong, another student can come in and say, well, I did this and got this answer instead. And then maybe a third student can come in and say, well, I agree with person A, I agree with person B. But I don't want any one student doing all 5 of these in the discussion board. Can you do them on your own in your own notes? I would highly encourage that. But for the discussion board, please only do A or B or C or D or E. So we're going to focus on 2. A. So write down how you would type these in Excel as a formula. This is 2 plus 4 all over 3 times 6 and then minus a 6. So when you have extra steps in the top or bottom of a fraction, that's a good sign that you need a parentheses around it. Now, the first thing you have to do for a formula in Excel is always type what? That's right, equals. So equals. Now, because the 2 plus 4 is in the top of a fraction, I'm going to go parentheses, 2 plus 4. Without the parentheses, when I do this slash for my division, it would think just the 4 was the top of the fraction. Now, the 3 times the 6 is in the bottom of the fraction, so same idea. Let's put 3 and then use the star for the times, because that's how you would have to type it in Excel, 3 times 6, and close the parentheses. The top of the fraction, parentheses, division for the fraction. Bottom of the fraction, parentheses, because of the extra numbers and everything. This minus 6 is to the side of it, so just a minus 6. That's it. B. So we're doing this in Excel, so the first thing we type is equals. That 5 is isolated and by itself, so just a 5. And we have a plus sign. Now the 2 is the top of the fraction. There's nothing else going on with it, so I don't need a parentheses around it. I could put a parentheses like this and it's not wrong, but it's just extra things that we don't need. Extra things tend to make us make mistakes. So then the fraction bar counts as our division. Now there is a bunch of stuff going on in the bottom, so we will need an open parentheses. Heck, it even has one in there for us, kind of demonstrating that. And in that parentheses is an 8 times 4. Then it closes it. And then we have an exponent of 3 plus 1. Now your exponent key in Excel looks like this. It's an upside down V, and that is Shift 6 on your standard keyboard. Now I'm going to do this wrong for a second. I'm going to pull out the red for wrong. The exponent, if you can't see, if it's too small, that's 3 plus 1. Red for wrong, red for wrong, red for wrong. Why is this wrong? Because this says the exponent is going to only be the 3. This exponent is only applying to the 3, and then the plus 1 counts it as out to the side. So that would be like this plus 1 is no longer the exponent. It's kind of like the 5. It's just another number being added. So to make sure that the plus 1 is part of the exponent, and this will be a theme that pops up throughout the semester, you need to wrap it in parentheses. 3 plus 1. Now you might say, well, Mr. Beckner, why not just write 4 because it's 3 plus 1? I like the idea here for this problem, but we're usually doing Excel references, so this is probably like cell C3 and cell D3, and you wouldn't just be able to say C3 plus D3 is Q19. I don't know. You wouldn't want to do that. So when you have complicated exponents, exponents that have pluses, minuses, anything like that, you need to wrap them in parentheses. And that was it. C, it's an Excel formula, so don't forget the equals. You forget the equals, it's wrong, and that would suck. Again, this one kind of has the parentheses already in place, it feels like, but it's actually not good enough. So let's do this wrong at first. So some students would go, oh, parentheses, 9 plus 2 slash 8 minus 11, and I'm going to stop here. We're already wrong in 2 spots as well. Because this fraction has got the 9 plus 2 in the top, but because the 9 plus 2 isn't in its own parentheses, this is the only thing that's the fraction. This is 2/8, and then a 9 being added to the left of it, and a 11 being subtracted to the right of it. This red does not look like what C started out as. So that was wrong. So that says we were supposed to have, so here's the parentheses for the whole fraction. 9 plus 2 slash 8 minus 11. That outer parentheses is the one seen in the example. But to make sure the 9 plus 2 go on the top of the fraction, I'm going to need, and I'll pick a different color. Let's go with green. This extra parentheses to make sure that's the top of the fraction, and you also need one around the 8 minus 11 to make sure that's the bottom of the fraction. Then we have this 4 times 6 as an exponent, so we'll need the caret. That's what that symbol is called, the upside down V. If I do this, it's wrong. I'm not going to pull out the red again. First of all, it's wrong for 2 reasons. I made a plus sign instead of a times. I did that intentionally. I did that incorrect in a class last week, unintentionally. So I wanted to make that mistake intentionally right now, but I'm not going ahead and make it. So that was supposed to be a times, so that's wrong. And also, this says the exponent is just the 4, and it would have a times 6 way out to the side, like how that minus 1 is. So for times 6 wrapped in parentheses, that takes care of the whole fraction, so then we can just go minus 1 to the side. So again, so far right now, all I've given is 5 questions. I'm going to scroll down quite a bit. Oh, I wish I had the answer one pulled up. That's okay. So here's that BMI Excel preview I mentioned from earlier. This is the formula you'll be typing in an Excel. It's got a product in the top, it's got a product in the bottom, an exponent in the bottom. It has 1 parentheses there, but spoiler alert, you're going to need more than 1 parentheses for this whole problem. And this is the thing that you're going to need fixed rows and fixed heights, or excuse me, fixed columns. Height was a poor word choice there. One of these 2 things will need the row fix. One of these 2 things will need the column fix, just like with the multiplication table. So practice the multiplication table before you try doing this. Now with that, they don't give you as many kind of hints and answers as the heart rate did. But it does at least give you a couple here, maybe not, maybe not. So 27.2 computed body mass index with this height in inches and this height in, this weight in pounds. So using the 62 and the 145, this is what the answer should be. So that should give you a helpful hint when you're working on that Excel homework. Okay. The last thing I really want to show you for now in this that I'm going to cover, this is what I was alluding to earlier, the crazy formula that we won't deal with till the end of the semester. This is the payment formula for a car loan or a mortgage, which is a house loan, or a boat loan, any fixed rate loan, unlike a credit card. Credit cards might be fixed rates, but you can adjust the balance by adding or subtracting to it. Whereas typical loans like cars, homes, boats, anything like that, you're only subtracting the balance over time to ultimately pay it off. This is a big, hairy, crazy formula. It's got a negative exponent. That complicates things. Complicates them quite a bit, in fact. Why do I have the same page twice? That's weird. So this formula, what the guided activities want us to do ultimately is what formula is entered in cell E2 using these 4 cell references. So this yellow highlighted number right here, this 289.99, this is acquired by using the 15,000, the 6%, a monthly payment system, compounding system, and then 5 years, all thrown into this formula right here. But they want to know what it looks like in Excel. Let me just kind of back out. I'm sorry that this is a little tiny. That is a negative NT is the exponent, but I just want to be able to have all this on the screen to show you what it looks like. This is the answer. equals. So the P times APR over N, you have to put a parentheses for that. Then the negative NT, because the exponent's a little more complicated, you'll have to wrap a parentheses around that, along with all the other parentheses you see. But that'll be good enough. So you go equals, open a parentheses, that's the black one I made. Then the principal is this cell right here, which is the 15,000, but the cell is A2. So cell A2 times. Then we're supposed to take the APR, which is in cell B2, so B2, then divide it by the N, which is in cell C2. And then we will close that parentheses, because that's the whole top of the fraction, slash for the fraction or the division, open a parentheses, 1 minus, open a parentheses, 1 plus. That's literally just this stuff right here. APR over N, cell references again, that's the B2 over C2. Then we'll close that because that's all of the denominator. Except for the exponent part. But since the exponent is complicated, we go parentheses after the caret, negative, but NT, the N was C2, the T was D2, so C2 times D2. You close the parentheses for the exponent part, then you close the parentheses for the entire fraction. So I'm not asking any of you to do that. We will not have any homework with a crazy complex formula like that for a very long time. The previous answers are pretty clear cut and dry, 1, 2, 3, and 4. These will be also part of your discussion board. So that's page 39, 1 through 4. Again, 1 student each. 1 student each. So page 39, questions 1 through 4, but not 5. So I got to clear my screen. I got to come off of annotate. So discussion board. And then page 39. The other page was 37, by the way. And I'll have all this on the screen at the end. So 39, 1 through 4. 1 student each. That's 9 opportunities. Remember, you don't have to answer a discussion board every single time. If I only have 15 potential answers and they're all right on the first try, not every student gets an opportunity maybe, but that's okay. There's plenty of other opportunities. You don't have to do every single one. All right, taxes is next. The BMI was next. Here's my next page. That's fine. Okay, we're good. All right, back to our notes to share. Simple solving of equations. This is just basic algebra reminders that we should all be capable of. Again, this is prereq material. Practice if you're rusty with your algebra. With solving equations, the main idea is whatever you do to one side, you do to the other. And you always work in opposite operations, where addition and subtraction are opposite operations, and then multiplication and division are opposite operations. So for example, if we had 2x plus 3 equals 5x minus 7. The goal is to get x solved for itself. Again, this has nothing to do with Excel. This is just standard math that you'll have to do every now and then in here. You got to get the variables on one side, the constants on the other. So does it technically matter if you move the 2x or the 5x? No. Me personally, I prefer moving the smaller one, but you can certainly move the 5x. It just means you'll have a negative variable that you'll have to divide out in the end. So I want to move the 2x, so I'm going to subtract it because it counts as being positive. It counts as being added. And it's not because of this plus sign. This plus sign is not why I'm subtracting 2x. It's because there's an imaginary plus sign here with that 2x. That's why we subtract it. Doing so will give us the 2x's cancel, so we get 3 equals. 5x minus 2x is 3x. Bring down the minus 7. Make sure you're keeping your notation accurate. I don't care if you're showing your work horizontally, vertically, or not at all. Just be capable of doing it. Now, since the x is on the right, the 7's got to move left, so we need to add 7 to both sides. And you might say, why aren't you dividing by 3? I'm going to save that for last because it's easiest. Technically, I could divide by 3 in this moment, but it complicates things. 3 plus 7 is 10 equals 3x. The 7's cancel. Then we divide both sides by 3 because that's 3 times x. We are not subtracting, we are dividing. 10 divided by 3 does not divide out perfectly, so I'm actually just going to leave that as 10/3. The 3's cancel on the right, so 10/3 is our x. That is also 3 1/3 or 3.3 bar, but you could not say it's 3.3 unless it told you to round. It'd be 3.3 with a bar over it. So that's 3. What happened? Where did my pen go? Why aren't you working? There we go. That's 3 1/3 or 3.3 with a bar over the 3. But if I did this, that would be wrong because that's a rounded answer. Now, if they told you to round, that's fine. But if they don't tell you to round, you better not round. All right. I'm thinking. Yeah, this is really short. We got time. 1.3. 1.3 is the shortest notes to share. There's not a lot going on, but I do want to go ahead and get the discussion board up for it. That way it's not just 9 answers. So the good thing is we can go ahead and just quickly talk about this and then go straight to page 44, 45. Just 45 technically is needed, but 44 sets it up. This payment formula, this is the Excel version of what you saw earlier. You still see on the screen right here. So this is the Excel version without the cell references. It's using the letters, and you can see that the parentheses are set up exactly as they were before I had to erase the screen. Again, this is above our pay grade for now. This is something we'll see in chapter 9, but for now, I'm just showing you an idea on how more complicated mathematical expressions, functions, formulas, whatever you want to call them, can be placed into Excel ultimately. But for now, we're keeping it a little simpler. This is really just a reminder, again, technically, but just to be safe. If you're ever asked about domain and range in my math lab homeworks, I don't really test on this, but domain is how far left or right a graph goes, and range is how far up or down it goes. We did discuss previously that the domain is your list of inputs, your range is your list of outputs. Domain relates, or inputs relate to the x values, range relates to y values for your traditional math things. We don't always have y's in here, and they're not always x's in here. But in terms of your standard rectangular coordinate system, your x values go left and right, aka your inputs go left and right. And then your outputs, your y's, your domain, I'm sorry, your ranges, they go up and down. And then this is just something that is a constant issue throughout the semester. Pay attention to where your units are. I'm not going to get too heavy-handed into that right now, but this is going to become a constant issue once we get into chapter 3. What do I mean by where the units are? I traditionally mean whether they're in the top or bottom of a fraction when we see numbers with units. So this is just kind of foreshadowing for now, but it's a good idea to go ahead and get used to paying attention where units are. For instance, like this principal, the dollar symbol would be in the top, not the bottom. This percent symbol would be counted in the top, not the bottom. If I had something like 3 inches, that inches counts as being in the top, not the bottom. Versus, say, if I had 3 on top of 1 inch. These are completely different things. Having an inch and a top, this is our traditional idea, 3 inches. This in the bottom, this second case, is actually 3 per inch. That's what that second case means. The left one is 3 inches, the right one is 3 per inch. So whenever you have units in the bottom, it means there's a per involved, P-E-R, not like the cat sound. And this is going to be a common theme for many, 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 many months once we get into chapter 3. Not as big of a deal for now, but a major, major issue moving forward. So, I mean, really, that's all I have to share for 1.3. Just a couple of minutes. It's nice and quick. But we can go to the guided worksheet, not out, in, not that far in. There we go. Mouse wheel got a little excited, didn't it? These definitions in 1.3, and here's those cash symbols again. So I've littered this all over the place. It's in your textbook, which I didn't show any of today really, because I didn't feel it's necessary, but you can still go through and look at it. It cross-references one or two things from these guided activities per usual. But this idea of what we call what-if analysis, you're going to see me talk about this in the next class a little more. But what-if analysis enables you to go through lots and lots of scenarios of things. All right, so I'm going to go get a car loan for 5 years and it's a 5% car loan. But what if my credit was a little better and I could get a 4% loan? Or what if my salary was a little better and I could take a 3-year loan and be able to pay it off? Or what if my salary sucks and I got to get a 10-year car loan? Or what if my credit is trash and I got to get a 10% loan? So you can go through all of these options. A lot of people think, oh, when I go buy a house or a car, I got to go talk to the loan officer to find out what my payment's going to be. I mean, you might need it for the exact number, but you can get a ballpark number really easily if you understand your credit score, if you know what the common rates are for good or bad credit scores, and you can just plug them into that formula we saw earlier. But very often these what-if analysis, you'll be using Excel because you'll be going through dozens or hundreds of scenarios. And very often in those, you'll need to be using these mixed or absolute or relative cell references. You might need cash symbols sometimes. Sometimes you don't, sometimes you do. Sometimes you got to fix a column, sometimes you got to fix a row, sometimes you got to fix both. So again, very helpful reminder, pretty much the same language we've seen already. But yeah, what if analysis? What if I borrow more money? What if I take out 17 grand instead of 15 grand? You know, maybe the car costs 17,000, you've got 2 grand in your pocket, and then the dude says, hey, you don't have to put the 2,000 down. We'll let you take the 17,000 loan. You go, well, you know, that'd be nice so I could sit on this $2,000, but then my payment's going to be higher the more you borrow, the more you pay. The longer you borrow, the more you pay. The higher interest you borrow with, the more you pay. Those are all positive correlating factors. And we'll talk about that idea throughout the semester. So the point of this is, okay, we start out, we had that $15,000 loan at 6%, paying it off monthly for 5 years. It ends up giving a payment of $289.99. We saw just this section alluded to earlier, just, let's blow it up. We saw just this section alluded to earlier, and you have 4 discussion board questions related to it. The answers are pretty much staring you in the face. Now what we're going to do is open this up. Instead of just that one scenario with 4 values, let's go through a different series of APRs and a different series of amounts of time. And let's see what our payment would be if we took a 1-year 1% loan. It turns out it would be $1,256 and some change. What if I took a 6-year 10% loan? It turns out you're paying monthly $277.89. Again, monthly. This isn't your total payment. This is your monthly payment. So you might go, wow, I don't want to take a 1-year 1% loan paying $1,200 a month. That sounds awful. I want the 6-year loan, and I'd rather pay 10%. I'll even take the higher interest rate because it's $277 a month. Well, no, I mean, that sounds better on a month-to-month basis, but you're paying this one off in 6 years, whereas you're paying this off in 1 year. In other words, you're taking 6 years, 12 months, so that's 72 months, versus 12 months in the 1 year. So you're paying this $277.89 72 times versus this $1,200 only 12 times. Also, I can guarantee you, you're definitely paying more for the car the more interest you pay. In fact, the absolute cheapest scenario up here at the end of you paying off your car is taking the 1-year 1% loan. Now, am I suggesting that's what you do? Not necessarily. It's really rough paying $1,200 a month for a car. We like to be in like the $300 range or less, maybe just a little more, you know, if we are taking a car loan. Me personally, I'm anti taking a car loan. I'm not into new cars. I'm not into financing things if I don't have to, but that's my own personal beliefs. And I'll give you logic and reasoning ultimately as to why I have those beliefs by the end of the semester, but I will never tell you what to do. I just tell you how to do things if you want to have more money in the long term. So this is where we're getting to our discussion board, and we're going to close out with this. For question 1, what are the two specific inputs, APR and term, for the highlighted payment of $456.33? So for this one, what APR are they using to calculate this, and what length of time? That's what they mean by term. How many years for that highlighted payment? So this is really easy to figure out. I've already kind of alluded to this idea with the multiplication table, but I don't want to super spoil it right here. But being in this position tells you exactly how long and at what APR you're financing. This yellow position would be different for one of those values, but not the other. Number 2, you're going to skip, because that would have that crazy formula I wrote down earlier on hand, but there'd be cash symbols in there as well. And I'm going to skip that. Question 3, how much total interest is paid with the $289.99 monthly payment? So question 3 we will be doing. I'm going to give you a hint. The answer is in the 2,000 to 2,500 range. That's the only hint I'm going to give you with question 3. How much total interest is paid with so let's say you took the 289 payment. So 289 payment, that gives you a certain number of years you're paying it and a certain APR you're paying it. But we don't really need to know the APR. All you need is the years, because I gave you some formulas in the chapter 1 notes to share, and they were bolded, and we said they were super important. How do you find your total number of payments? Take the number of payments times the loan term. How do you find the total paid? Number of payments times payments. So you'll be using those. How do you find total interest? Take the total you pay minus the principal you borrow, which was that $15,000. So you'll have 3 steps. So total paid and total interest. The total number of payments has to be done first, but that feels like a more implicit step to a lot of students. So that's how you get question 3. You'll have to go through those 3 formulas, if you will. Question 4, how much would you save in interest if you switched to a 3-year loan? So they give you the answer for how long and what APR this is, which basically tells you how to do the one for the blue box from question 1. But what if we switch to a shorter term loan? Going to a shorter term loan, spoilers, you will save money. So you'll have to, someone will have to do the exact same calculation that they did for question 3, but this will be another student. But now instead of using 5 years 6%, they're doing 3 years 6%. So you'll find the payment in the 3 years 6%. I'm going to point at a wrong one. This would be a 1 year 5% in particular. That's not the one you use. So you find the right payment amount. You multiply by the number of payments. You'll subtract that amount from the principal to get the interest. But then they say, how much do you save? So let's say the answer is number 3, that the interest was just $1,500. It's wrong. Let's say the interest for number 3 was $1,500. And let's say the interest for this scenario right here was $1,000. If this one costs you $1,500 in interest and this one costs you $1,000 in interest, that makes the savings $500, the difference of the $1,500 and the $1,000. Again, not the exact answers, but that tells you how to do it. Question 5 is basically the same thing as question 3, but it tells you which scenario to look at to find the payment. Question 6, your answers are going to be both, row, neither, or column. So spoilers, this one's both. There is not another one that's both. So this answer might be row or column. This answer might be row, column, or neither. This one might be row, column, or neither. This one might be both. I've already said it's not, but that's what we're doing for question 6. 1, 2, 3, 4, 5, 6 of those. So for the discussion board, we're skipping again. We're skipping question 2. So it's just 1, 3, 4, and 5. Sorry, 1 and then 3 through 6. And I actually want 1, 2, 3, 4, 5, 6 students to do number 6. So that's going to
So that will close out chapter 1. And now we're about to start chapter 2. And of course, we'll start with the first section. 2.1 is going to be on ratios. And this idea of a ratio is going to be continued to be discussed for the next chapter, and then the next chapter. And then even when we're getting into chapter 5, we're still going to be talking about the idea of ratios most of the time. And when we aren't doing it most of the time, it's ratio adjacent, just so you know. So again, we have finished all of chapter 1, which is why that homework will be due in a week. We will not finish 2.1 today, but because it's a very, very long section, but let's go ahead and get into it.
Let's get into chapter 2. And chapter 2, chapter 3, and chapter 4 are all very, very, very heavily tied to each other. Chapters 2, 3, and 4 are all very heavily tied to each other. Now, in fact, the rest of this course is very tied to chapters 2, 3, and 4, but we start expanding in bigger ways once we get to chapter 5, but let's not get there yet. We don't want to jump the line too soon. So ratios and proportions. This is an idea that we're going to study and discuss over and over and over and over and over. And we can approach this concept in a very simple way. We can take it one step further, and then we can take it another step further. So the simplest way is where we talk about setting a fraction equal to a fraction and cross multiplying to solve. That's the simplest way. What we can do after that is turn it into an equation involving this y equals kx that we'll see later. And then the next step is taking the idea of proportions and creating equations with them where they're not actually proportional. The idea of being proportional is there as a base, but there's something else going on. They're maybe inversely proportional or proportional with a square or a square root of something. So again, that very base idea, we're going to extend and extend and extend. But remember, we're taking this slowly. So let's start out with something small first. What is a ratio? A ratio is a way of comparing two sets of data that vary with each other. So specifically, when we talk about the idea of a ratio, sorry, I'm getting my colors set up. Ratios, fractions. Ratios are just fractions. The word ratio has the root word rate inside of it, and you'll hear that word described with fractions as well sooner than later. So whenever we talk about ratios, we're talking about setting up fractions. So a ratio is a way of comparing two sets of data that vary with each other, something like apples to oranges. And in fact, let me just bump some of this down that we don't need to see yet. TMI right now, there we go. A little less TMI, a little less I guess. So when something follows a ratio, it means that if one of these values is going to go up, the other has to go up as well. And they're going to go up in a similar fashion. It's not one of them goes up by 1 and the other goes up by 5, and then the next time the first one goes up by 2 and the second one goes up by 3. That wouldn't be a proportional relationship using ratios. A proportional relationship would be like something increasing by 1, thing 1 increases by 1, and then the other thing increases by 2. Then if the first one increases by 2, the second thing increases by 4. There's a multiplicative or divisive relationship between them. So data that is proportional will see one increase as the other increases, and thus can be set up as a ratio. So if your apples go up, your oranges go up. That means that the data is likely proportional. Now I said likely because just because these two things go up together doesn't mean they're proportional. They have to go up in a similar relation every time. And we'll get into a very useful, I don't want to say trick, but a way of telling if they're proportions ultimately. So when you're doing your homework, most, if not all of these problems, you're going to be told, hey, these things are ratios, these things are proportions. which means was one thing goes up, the other goes up in a similar manner. But in the real world, which is what this quantitative reasoning class is really all about, ultimately, it's not just getting math problems right in a homework set. It's about extending these concepts into the real world for your own personal use. So in the real world, you may need to ask yourself if something is proportional. So what you do is you ask yourself, if one value goes up, does the other have to go up? And again, there would be a specific numerical relationship between those, which we're going to get into. But that's what you would ask if you think that two things are proportional. So you're running a store and you sell apples and oranges, and you think that there's a proportional relationship between the amount of apples you sell and the amount of oranges you sell. This is what you think. So you'd ask yourself as the store runner or manager or whatever, all right, when my apple sales increase, did my orange sales increase? And then on top of that, if you say yes, then you say, all right, well, is there a relationship between these numerical increases? Now, again, when you're doing your homework, when you're taking your tests, this is not really the main issue. It's not you asking if they're proportional. It's you'll be told that they are, and you go ahead to the mathematical relationship. Again, this highlighted statement is more real-world scenario stuff. Also, discussion board level stuff or things from the guided worksheets more specifically. So when we're talking about those, again, those guided worksheets are more like us in the real world, if you will. So this idea will come up as we'll see. Now, when you actually get to the solving of your proportions, there is a main trick that I am going to always do, and I suggest that you always do as well. I highly suggest it. I would demand it, but it's hard to demand things when I can't watch over your shoulders constantly, right? So just pretend that I demand this of you. Write your ratio in words for consistency. Use your words. I can't tell you how many people make mistakes with these because they don't use their words, because they don't want to take the extra 10 seconds, and that's it, to write apple over orange or miles over gallon or students over teachers or pens over, I don't know, elephants, whatever the two things you're comparing. So please, please do that because it will save you a lot of hassle over time. Why is the highlight not going away? There we go. All right, so what do I mean? So let's say you have this problem involving apples and oranges, and you either discovered that they're proportional or you are told they're proportional. Then you would write apples over oranges. This would be the first thing I would do before injecting any numbers and solving any equations. And it doesn't have to be apples and oranges. You could be just comparing some random first thing to some random second thing. Pennies to quarters, students to teachers. Does it matter which one you put on top? In fact, no. And that's the whole point of this. That's the beauty of ratios and proportions, is that when you're dealing with proportional relationships, you could write apple over orange, or you could write orange over apple. You just have to be consistent. Writing the words out top over bottom is going to tell you where to put your numbers. So if student A, all right, so say we got a problem with 2 apples and 3 oranges. Student A writes 2 over 3 because they wrote apples over oranges first in terms of words, but then student B might write 3 over 2 because they chose to do oranges over apples. That's perfectly fine because when they set up the rest of their proportion, they'll continue to do whichever they said they're going to do, apples over oranges or oranges over apples, and everything will be okay. Again, it's consistency that is key. Monday over Tuesday, week 1 over week 2, scenario A to scenario B, however you want to do those. So you're going to be setting up equations where it's a fraction equal to a fraction. A proportion is an equation where it's a fraction equal to a fraction. That's our first idea of a proportion. A proportion is a fraction equal to a fraction. Yes, there's another way to write those out as equations. That's phase 2. We'll get there another day. For now, a proportion is what? A fraction equal to a fraction. It's a ratio equal to another ratio. It's the ratio of apples to oranges in the first scenario to apples and oranges in the second scenario. So again, a proportion for now is a fraction equal to a fraction where your units, words, ideas, concepts, items, whatever you want to call them, are consistently the same on the top and the same on the bottom. How do you solve these? This is something you should have seen before in a previous math class. This should be a reminder, but if not, here it is. You cross multiply to solve a fraction equal to a fraction. So your proportions starting out will look like this. A over B equals C over D, where A, B, C, and D would be numbers given in the problem. Maybe three of these would be numbers and one of them would be missing in general. So again, typically 3 of these would be numbers and 1 would be an unknown, and you would be able to solve for it by cross multiplying. Cross multiplying means to take the top of one and multiply it by the bottom of the other. And then you set it equal to the exact opposite pair being multiplied, the bottom of one times the top of the other. So you would get, sorry, I went blank for this. This is just me saying I'm changing the equation to this thing. I've done some math. The A times the D, that was multiplying the top left and the bottom right, set it equal to the B times the C. That's how you solve a proportion. You cross multiply, top left times bottom right, set it equal to bottom left times top right. If you swap the A and the D, nobody cares. If you swap the B and the C, nobody cares. It is this idea right here that makes it so it doesn't matter whether you did apples over oranges or oranges over apples as long as you're consistent. Because the whole idea of the tops and bottoms are going to go away, there's not going to be any more fractions once you hit this point. So if you did apples over oranges, you're not going to be able to tell that anymore once you hit this point. If you did oranges over apples, you're not going to be able to tell that anymore once you hit this point. And when you solve, if you don't make mistakes, you would get the same answer either way. So it doesn't matter whether you do apples over oranges or oranges over apples. Once again, I'm just saying this over and over. You have to be consistent. As long as you're consistent, the order you chose, apples over oranges or oranges over apples, doesn't matter. Just be consistent. All right. So we already said this. A proportion is 2 ratios set equal to each other. A ratio is a fraction. So that's no surprise what we just did up there. Couple small little memos that will pop up here and there, especially in the guided worksheets, as you will see as we work together. Very often we'll want to scale something to 1. This can be used in model scaling. This can be used in the idea of just trying to get a simplified or reduced number. This can be used in a lot of ways. And we will, again, be diving into this concept of scaling something to 1. But when you want to scale something to 1, you will make the requested value 1 and then solve the proportion. So you would be maybe told, all right, 2 apples to 3 oranges. And then they say, scale the apples to 1. So 2 over 3 would be one of your fractions. And then on the other side, the apple on the top, assuming it would be apple on the top, would be 1. So again, if I had something like scale 2 apples to 3 oranges to 1 apple, you'd have 2 over 3, because we're going apple over oranges, equal to, and because I said to scale the apples to 1, we'd go 1 over x. This would be our unknown. So the 1 is where the apples were. If I said to scale the oranges to 1, then the 1 and the x would be flip-flopped. So they generally tell you what to scale to 1. If for some reason they don't, some people will say scale the smallest to 1, some people will say scale the biggest to 1. What I find is most common with this course is that you scale the second value to 1. So if they don't specify which one to scale, it's generally going to be the second thing that they said. And as I said, we will see these issues addressed with the guided worksheet activities we'll be covering. How many times have I said this now? I just like to inject these statements again every now and then. I'll put those fixed cell references back up at some point. But remember, when you're doing things in this course, don't just do the math and move on. When you get an answer, ask yourself if the answer makes sense. When you're doing your work, read the question carefully, read it again, pay attention. Make sure you're using your words. All of these things are super important. Being what's the word I'm looking for? Detail oriented? That doesn't sound right. Detail minded, whatever that word is I'm looking for, paying attention to the details is extremely important. And we know nobody's perfect. Your teacher makes mistakes. You will make mistakes. But when you pay attention and ask yourself if things make sense, we often find those mistakes and fix them. I make lots of mistakes, but I get answers that don't make sense. I go back and find the mistake, and then I fix everything because I choose to pay attention. I choose to take my time, be detail oriented. Yeah, that was right. I don't know why it just sounded weird at first. Okay. Before we get into this proportion table, let's actually go ahead to the guided worksheets, and we are gonna, oops, wrong window. There it is. Nice little summary. You can read this on your own. We don't have the time to get into all that detail, but it talks about the main point of this is how in 2017, the number of US births was 3.8 million. And in 2017, the number of Mexico births was 2.3 million. Again, rounding out. So you might say, oh, well, the US had way more births, but well, that might be true in an absolute number, 3.8 million versus 2.3 million. What we want to do a lot of the time is think of this as a proportional relationship. Think about this as a relationship to the size of the country. So we had 3.8 million births, but what was the population that year? Mexico had 2.3 million births, but what was the population that year? What is this growth, these births, in comparison to the original population? So Mexico had a population of 129 million people, whereas the US had a population of 324 million people. So the US has about, I'm rounding, 3 times as many people, and yet their number of births, 3.8 million versus 2.3, is not 3 times as many. If they were, this would be in the 6 or 7 million ballpark, but it's about half of that, roughly, the 7 million, that is to say. So this isn't really a proportional relationship when you wanted to just say, you know, US to Mexico versus their birth rates. When you look at them as singular proportions, the US alone and Mexico alone, you can see that there's 11.88 births per 1,000 people. So this is a very common type of proportion where they compare it to a per 100 people or per 1,000 people, as we will see moving forward. So there was about 12 births for every 1,000 people in the US, but there was about 18 births for every 1,000 people in Mexico. And what that means is Mexico is growing quicker, at least in the year 2017. They have more births in this sense when you think about it as a base value of the population. Then they mentioned that only women of childbearing age can have babies. So of course, maybe we should be comparing births to the number of these women instead of the entire population. Men can't have babies. Women that are too young or too old can't have babies. So they say maybe we should just be looking at this as a relationship or a proportion to the childbearing aged women. So that's another important concept. How are we comparing these two numbers, our apples and our oranges? Does it make sense to compare the number of births to the entire population, or would it make more sense to compare the number of births to the childbearing aged women? And that's something that we can study in a real world quantitative reasoning sense. All right. One of the few times where I will just annotate on this, just to keep things simpler so I don't have to type in another screen and keep going back and forth, but I'll have to erase it ultimately after this page is done. But you've got the video to review if you need it. All right, so I can't read this top part. Ratios compare the relative size of two quantities that I refer to as thing one and thing two. When I say I mean them, this worksheet. So apples and oranges, thing one, thing two. Apples, thing one, oranges, thing two. Identifying thing one and thing two is trickier than it seems often because ratios are presented as single numbers like the birth rate in the US. We talked about the number of births versus people. Number of births would be thing one, the people would be thing two. So what we're going to do is go through most of these, not all of them. What are the two quantities being compared in the following ratios? Be careful not to confuse units with actual quantity. Now, this little sentence right here, be careful not to confuse units with quantity. Since we're just using our own words, I honestly would not care if you confused units with quantity. So I will give that as an example. What is it, the fifth one? Yeah, the fifth one. So the gas mileage of a Subaru Outback is 35 miles per gallon is a ratio, but the quantities are not miles and gallons. Those are units for the underlying quantities of distance and gas. So that's the idea there, that they're saying that the ratio, the thing one and thing two are distance and gas, that you shouldn't write miles and gallons because miles is a type of distance and gallons is a type of amount of gasoline. I kind of disagree with them though. I mean, honestly, as long as you understand the information you're conveying, why can't you call thing one miles and thing two gallons? So I just kind of disregard that really. It's not an issue that's going to come up in the homework or the test, so it's fine. Use your own words. Use whatever words you like. All right, this first one, GPA is 2.74. I still can't believe that they don't tell students this anymore. This is a ratio of something we call quality points. Let me actually do the text. Let me see if that'll be good. That's going to be too big. So that's a no. Quality points. Sorry, my handwriting is a little worse on this. As I mentioned, there's no algorithm fixing it. So if that's thing one, and thing two is the number of credits. So quality points are how many A's and B's you've had and how many actual points you get out of it. So like A is worth a 4, but if you have, if it's a 3-credit class, that means you get 12 quality points. Because you get a 4 for credit 1, a 4 for credit 2, and a 4 for credit 3. Don't worry about that one too much. If this was 15 years ago where they were still telling students this, I'd label it more importantly, but let's just move on. Only one US adult in 5 could calculate interest. Now, this problem right here is going to lead to a common theme for like half of these down here. Only one US adult in 5 could calculate interest. This is not saying one adult to 4 adults, so 1 can and 4 can't. This is not a thing one is those who can and thing two those who can't. This is the people who can, so the adults who can calculate interest to all adults. This is a very important type of proportion where we're comparing a part of something to an entire population. So 1 out of 5 can calculate interest. So that means there's 1 adult who can to 4 adults who can't, for a total population of 5, which means if there were 10 people, 2 would be able to calculate interest and 8 would not be able to, but that ratio would be 2 to 10. 2 adults who can out of all adults. And then 2 to 10, you could reduce to 1 to 5. If I had 100 people in total, that means 20 would be able to calculate interest, and then there'd be 100 total, meaning 80 couldn't. So this is what we call a part to whole ratio. This is very, very common. And again, it's going to be the answer to like half of these. 13% of the US adults are numerate. So again, it really only feels like they gave us one thing, a percentage or a ratio of people that can do something. So once again, this is the thing one is the people that can or can't do the thing, and thing two is everyone. So it's the adults who are numerate, which means people who are good with numbers. Adults who are NUM for numerate. And then this is all adults again. APR of 6%, this is going to be the ratio of interest to balance. This is actually a rearrangement of the interest in dollars as a product of the periodic rate times the balance. This would just say that interest divided by balance is APR. So it's just an algebraic rearrangement of equations, so I went ahead and gave you that one. Speed is 75 miles per hour. The word per means the next thing is the bottom of a fraction. It would be thing 2. So one person might say, and I'll do this in blue because this is technically breaking the rule above, but your teacher says he doesn't care. Miles could be thing 1, and hours could be thing 2. Or you can be more specific, and instead of using units, use the quantity. Miles is a type of distance, and hours is a type of time. So the red words are a little more better, a little better. The blue is a little more generic because I could say, instead of miles per hour, I'd say kilometers per second, feet per day. I could make any 2 word choices for distances and times. It's, of course, best to use the 2 they use, but I could still arbitrarily switch the miles to kilometers, and it doesn't change anything about it. It would just be weird. Half of 17-year-olds don't know enough math to work in an auto plant. Half of 17-year-olds don't know enough math to work in an auto plant. So since they used the word don't this time, instead of saying the people who can to the total population, we say those who can't. So the 17-year-olds who can't, ... I don't have enough space to be able to write all that, who can't do enough math or don't know enough math, to all. Now, it's not all people, it's all 17-year-olds. That looks like a 117-year-old. All 17-year-olds. There we go. I'm going to skip a couple of these. I might leave them for discussion boards. Again, I'm making that decision at the end of class, so hold on, don't leave early, or come back and watch later. We're going to skip this one. You borrow 300 and you pay 350. This one will be principal to new balance. The 350 being the new balance, the 300 being what you borrowed, the principal. These finance ones, I just wanted to go ahead and get out of the way. 52% we're going to skip. 15.5 we're going to skip. The 50.3 we're going to skip. The last one we're going to do. Apple Incorporated reported 9.21 earnings per share in 2017. Apple is an awesome growing company. Sure, they just had a little hiccup a few days ago in the stock market because of lots of reasons we don't need to get into. But I can almost guarantee they'll grow again. I mean, they've already gained some steam back. It's not just Apple, it was everyone in tech. Not the point of this, I'm rambling. So what this one is, they talk about reporting earnings. Then they use the word per, so the next thing would be the second thing. So the number of shares. Once again, the word per means the next thing is the bottom of a fraction, or it's the thing two, however you want to say that. So I'm going to label this A, B, C, and D. Again, these will be for the discussion board, question mark, if I assign it. But let's hold off on that idea for now. And that's page 64. All right, so I need to clear the screen. Let's come off of this. There we go. All right. Lots of space. Nope, not there. Lots and lots and lots and lots and lots of space. So what you're going to see a lot in this class is going to be a proportion table. If my audio is going in and out, I have a feeling my internet is having a problem again. I had a class, was it Thursday maybe, that it just kept cutting out and I had to record everything in multiple parts. I'm hoping that doesn't happen. So fingers crossed that it's going to keep working. If it crashes, we'll have to deal with it and just hang out, and I'll be back as soon as I can. Hopefully it doesn't crash. Proportion tables. This is something that you're going to see throughout this chapter as well as the next chapter. You'll see homework problems on this. You'll see test problems on this. You're going to be dealing with a lot of things called CPI, consumer price indexes, that'll use these. And you can be given these types of problems in giant, massive tables. And I will draw up an example in a giant, massive table after we do a simple table first. But when you're using a table, you need what I call 3 corners of numbers and a blank. You need 3 corners of numbers and a blank. These corners do not have to be all sitting next to each other, but you should be able to draw one box around all 4. i.e., you need all values in just 2 rows and 2 columns, but it doesn't matter where those rows or columns are. Now that might not make a lot of sense without seeing the examples. We're going to see the examples and get it to make sense. Don't worry. So let's start out with a small one. And we're going to do apples and oranges. So I could have given you a problem. And I'll also draw it up as a table. But I might say, all right, a store sells 2 apples on Monday, sells 2 apples and 3 oranges Monday. On Tuesday, store sells 6 apples. If there is a proportional relationship in the fruits, how many oranges sold Tuesday? This is the type of example you can see with this. Now, I've given this to you as a word problem, but I could have also just given it to you as a table setup. So I'm going to take the word problem and I'm going to set up the table, but just know that in your homework, they might just go ahead and straight up give you the table without the word problem. You have to be able to handle this both ways. So, thing 1, apples. Thing 2, oranges. So we're going to go apples over oranges if we wanted to just go ahead and do this straight up. So apples over, I'm going to abbreviate it, oranges. So that's the proportion I'm choosing, which means on Monday, that's the first side of our proportion, 2 apples and 3 oranges sold. So it's 2 over 3, 2 apples, 3 oranges. Apples are in the top, oranges in the bottom. Consistency. Then we set it equal to the other scenario. On Tuesday, the store sold 6 apples. So that's a 6. Apples, why do I know the 6 is the top? Because apples go in the top. How many oranges were sold if this is proportional? So we were told this is proportional, which is why I've chosen to set up this fraction equal to a fraction. We don't know how many oranges were sold, so give it a letter. Give it X in O if you want to be a little bit of a pain, because O looks like 0. Not my favorite letter choice, but you could do it. You're going to take this and you're going to CM, which stands for cross multiply. So we take the 2 times the X and the 3 times the 6. Here's the 2 times the X. You set it equal to the 3 times the 6. And that's 3 times 6 is just 18. So we get 2X is equal to 18. We went over how to solve an equation like this last time. You divide both sides by the number paired with your variable, divide by 2. And what you get is that X is equal to 9. Now, let's say you just box this up and ship it out in the real world. You say 9. That's not an answer. 9 is not an answer. You need to be asking yourself, what is X? X was the number of oranges sold on Tuesday. So it was 9 oranges. That looks like a T. Come on, undo work. 9 oranges on Tuesday. That is a quantitative reasoning answer. 9 is not a quantitative reasoning answer. 9 oranges would be good enough since they said specifically on Tuesday, but this is being very specific. 9 is not an answer. Now in my math lab, they generally have those words set for you already, so it's not really an issue, but remember, we're quantitative reasoning students because we're trying to take this and use it in the real world. We have to be specific, we have to use our words. Does that make sense? Well, Monday, it was 2 apples and 3 oranges. If this is a proportional relationship, that means if the apples increase, so should the oranges, and they should be increasing in a similar manner. Now, I haven't described what that similar manner is yet, but we will shortly, probably today, maybe today, maybe next class, we'll see, but I'll tell you the specifics sooner than later. So 2 apples went up to 6 apples, so the apples went up. 3 oranges went to 9 oranges, they went up. So as far as we know for now, that makes sense that they're a proportion. Now you might say, well, the apples went up by 4 and the oranges went up by 6. Those aren't the same number. But that's not what proportional relationships are. It's not saying that they increase exactly the same. It's that they increase with a constant ratio to each other. What it means is it's a constant multiplier. So that's kind of a hint as to what grand statement we'll have sooner than later. All right, so here's the problem set up as an official word problem, but alternatively, I could have just said the following table is a proportion. So here we have a proportion table. And I say we have apples. Hold on, give me 10 seconds. All right. Don't want to do there, a little lower. We have apples and we have oranges. And we sold some apples on Monday, we sold some apples on Tuesday, we sold some oranges on the same days. So 2 apples and 3 oranges on Monday, and then we sold 6 apples on Tuesday, and this spot is blank. Let me pull back, there we go. So this is a proportion table. This is how it could have been set up as well. So same exact numbers, same exact answer, just a different setup. When using a table, you need 3 corners of numbers in one blank. These corners do not have to be sitting next to each other. They are in this instance. I'll give you an example where they aren't next. But you should be able to draw one box around all 4 of these. And then that's what I'm talking about with the corners. You're going to draw a box, your own box around this somewhere. So like this would be me drawing a box around some numbers. And the goal is to draw that box so that 3 corners have numbers and 1 does not. This has a number, this has a number, and this has a number. So that's exactly what I'm referring to. So when you have your table, you're supposed to imagine yourself drawing a box. Some people like to draw it, some people just imagine it, some people ignore me and do their own thing and get them half wrong or all right, depending on their skill level. But this is us drawing a box in such a way that in this box, this 3 is in a corner, this 2 is in a corner, this 6 is in a corner, this blank is in a corner. Now you might say, well, obviously they're corners because of this scenario. It'll be a little more complicated next example. So 3 of these are numbers, 1's a blank. We can make a proportion out of this. Now here is the beauty of proportions. You can set these up 8, arguably 16 different ways and still get the same answer. I've already alluded to this fact because I said you could go apples over oranges or oranges over apples. It would have flipped this thing upside down. And when you cross multiply, you can't even tell anymore that you flipped it upside down. You'd get the same answer. So all we got to do is just make a fraction equal to a fraction using these numbers, either going top over bottom equals top over bottom or left over right equals left over right. It's again, you just need to be consistent. So I'm going to show this a couple different ways. The first one I'll show is my favorite way. So my favorite way would be to go just set these numbers up as a fraction equal to a fraction exactly as they look. 2 over 3 equals 6 over x. Top left over bottom left equals top right over bottom right. This is the easiest way in my opinion. I find it easy because the numbers are laid out in the proportion exactly as they are in the table in terms of their corners and positioning. This is exactly the same equation we just solved earlier. You cross multiply, you get 2x equals 18. You divide and you get x equals 9. The same answer. X being here. Wherever your blank is, you call it x. Or N or J for oranges, whatever letter you like. Here's an alternate way. Some people, and for some reason the guided worksheets really like to do it this way, they'll go from left to right. So they'll compare the apples, 2 over 6. So that was Monday to Tuesday. So for the oranges, you just have to be consistent. Monday to Tuesday, so 3 over x. Cross multiply, you'll get 2x equals 6 times 3, which is 2x equals 18. Clearly the same answer. Now, and I'm going to do this in orange since I got a lot of red on the screen already. A wrong way. Again, there is 8, arguably 16 different ways to take these 3 numbers in a variable to set up a fraction equal to a fraction and get the answer right. Instead of going 2 over 6 equals 3 over x, I could have gone 6 over 2 equals x over 3. I could go from right to left. Instead of going top over bottom, I can go bottom over top. 3 over 2 equals x over 6. After you cross multiply, that orientation is no longer visible. But you can still do this 8 or 16 ways wrong if you're just doing this, not paying attention. Because again, consistency is the key. Going left to right, going left to right. Top over bottom, or right over left, however you wish to do it. Doing this wrong way is maybe, all right, I'm going to go apples over oranges for the 2 over 3. I go top left over bottom left. But then on the other day, I flip it. I go x over 6. So I went top over bottom on the left and bottom over top on the right. That's inconsistent. So what you'd end up with is 2 times 6 is 12, and 3x. Dividing both sides by 3, you get 4 equals x. Remember, when you get these answers, you're supposed to be saying, does it make sense? What is this? This was oranges, so 4 oranges. Does it make sense? Well, the apples went from 2 to 6. They went up, I would say, significantly, whereas the oranges went from 3 to 4. There were more oranges to begin with, and the increase was smaller than the apples, of which there were less of. So no, this does not make sense. If there were more oranges on Monday, if the apples go up, there should be more oranges than Tuesday's apples. See, the apples went from 2 to 6. The oranges were bigger than the apples, so they should still be bigger than the apples. 4 is not bigger than 6. We did this wrong because we were inconsistent. So this was a simple proportion table because there were no gaps. Again, these instructions say these corners do not have to be all sitting next to each other as long as you can draw that box around 4 corners where 3 of them have numbers. Now, when I say box, I mean a box. I don't mean something that looks like this. That's not what I mean. You have to draw a rectangle. It can be a tall rectangle, it can be a wide rectangle, it can be a perfect square, but you can't zigzag. It has to be a quadrilateral box. So let's see the large and in charge example. And we're going to have a whole bunch of things. Let's go oranges, bananas, kiwis, watermelon, apples, limes, lemons, and then a fruit. I feel like he's kind of gotten lost in the history of things, tangelos. Those little small oranges that are like a half orange, half tangerine. And then we're going to have a whole bunch of days for these. We're going to go full week. I'm going to abbreviate the days, though, because this will get ridiculous otherwise. Monday, Tuesday, Wednesday, Thursday, which we're college students, we should know is R, Friday, Saturday we'll do SA. Sunday we'll do SU. And then just finish the horizontal lines. Big table, big table. Give you a second to do that. Okay, so not giving the actual word problem where we say on Monday the store sold 7 oranges, on Thursday they sold 1 orange, on Sunday they sold 11 bananas, for kiwis they sold 2 on Tuesday and 6 on Friday. For limes they sold 3 on Tuesday. Then for tangelos we sold 100 on Wednesday, and lemons we sold 12 on a Saturday, excuse me. So what we're going to do here is we're going to find the only value we are able to if all these are proportional. So yes, the store sold some oranges on Tuesday, Wednesday, Friday, Saturday, Sunday, bananas on the days we're missing, whatever. Maybe 1 or 2 of these were 0, but I didn't want to fill out this table entirely because then lots of answers would be findable, excuse me. So we are going to find the only value that we're able to if all of these are proportional. So only one of these is findable, I believe. I believe I drew that up correctly. Yes, we're good. And you might think otherwise, but we're going to draw a whole bunch of different boxes and we'll ultimately find the one that works. But we'll do them wrong first. So here's the reminder. We'll be down back there in a second. You need 3 corners and a blank. These corners don't have to be sitting next to each other. You can skip rows, you can skip columns, but you should be able to draw one box, one quadrilateral, 4 corners, around those, where 3 of them would be numbers and 1 would be a blank. And again, the real tried and true idea here is that you need values along 2 rows and 2 columns. It just doesn't matter where those rows or columns are. So I'm going to draw some boxes that are bad at first. Warning. So some people might say, all right, I can do a box right here. So here's a box. This is a bad one. So this is me drawing a box where the corners are here, 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 and here. Those are the corners. So this blank row, we're ignoring this. We don't even think about this for the idea of proportionality or setting up that fraction equal to a fraction. But this box that I've drawn with the corners circled, 2 are numbers and 2 are blanks. If we wrote this out as a fraction, 7 over x equals y over 2, because these 2 things are different, you can't make them the same variable, that would not be a solvable equation that would give us a value. That's why it's important that when we draw that box, 3 of the corners need numbers and 1 of them needs to be blank. So that box fails. All right, so what you might say is, all right, well, here's a number, here's a number, here's a number, here's a number. Maybe I could do it like this. Would this work? So now I've got a box, and inside of this box, there's 3 numbers. But are the 3 numbers on corners? The 7's a corner, that's fine. The 1's a corner, that's fine. This 2 is not a corner, though. This blank is a corner, and this blank is a corner. So that won't work either, because blank, blank, we can only have 1 blank to make the fraction equal a fraction scenario. So that fails as well. I said I'm going to draw a bunch of bad ones first. All right, maybe someone thinks this works. So, like I said, a lot of people just think you got to get 3 numbers in the box. This is actually the worst one so far. This is the corner of a 3. That's fine. But blank, blank, blank. Sure, the 112 are in there, but they're not corners. This is awful. That's 3 over x equals y over z. There's no way you're finding out what those numbers are. So that was a bad box. Some people might say, well, try just doing the whole entire thing. Definitely doesn't work. Number, blank, blank, blank. That fails. 2, 6, 3, 100. Maybe people are starting to kind of hone in on these. So maybe they do something like this. Would this work? Question mark. The 2 is in a good position. The 6 is in a good position. The 100 is not. Blank, blank. But the fact that the 2 and the 6 are on a completed row, or both in corners along a row, and then there's another number in the same column as the 2, this is a hint as to what you should be looking for. You want to look for a row or column where there's 2 values, and then find another number in this opposite row or column. So what I'm saying is, here's 2 numbers in the same row. If there is a number in either of their shared columns, so either another number in Tuesday's column or Friday's column, you can make a box out of it. And look at that, there's 1 for 3. Or maybe you notice that 2 and 3 are in the same column. So you'd say, all right, well, if there's another number in the same row as one of these, either the kiwi row or the limes row, then you can make a box out of that. And sure enough, there's a 6 there. So the 2, the 3, and the 6 are going to be our ultimate box. Let me go with that idea again before we draw it correctly, though. Maybe you notice, oh, 7 and 1, these are in the same row. So you say, well, these could be 2 corners, but then you need a number either in the Monday column or the Thursday column. All of these are blank, all of these are blank, so you can't use the 7 and the 1, at least in that regard. You might say, actually, that's it for all the different scenarios, because the 12's in a column by itself, that won't work. Row by itself won't work. 100 row column by itself. So you see the 2 and the 6, that might have been a good hint. And then you say, hey, that 3 is in the same column as the 2. Excuse me. I was focused on my going too far there. There we go. That's better. Boom. This is the correct box because we have 3 corners with numbers and a blank that we can call X. Now, I actually chose these numbers exactly as the same as the apples and orange problem as before, so that you already know what the answer should be. What that tells us is that we get 2 over 3, so corner over corner. So I went top over bottom, so be consistent, top over bottom, 6 over X. But again, there are 8, arguably 16 different ways to set up that proportion to ultimately get 2X equals 3 times 6, 2X equals 18, divide by 2, and you get X equals 9. So that would be 9 limes, because that's where X is, on Friday. So in the previous example, the 2 and the 3 were talking about apples and oranges. Now I've made them kiwis and limes. So that's why this is not going to be oranges anymore. This unknown was in the limes position. I did that intentionally, just to keep us on our toes. I didn't need any, there could have been numbers here. 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 You don't use them. You are able to skip rows. You are able to skip columns. This is a common theme in this course. Lots of homework, test questions, guided worksheet questions. This is going to be a common theme. It doesn't matter how far these rows or columns are separated as long as you can draw a box out of them. Now, what happens a lot of the times is once you get this corner, maybe that would enable you to find another one. So now I've got these 2 here. Maybe there's another number I could then find, but there isn't for this example. I did make it so there was only one value you'd ever be able to find. But in our guided worksheets, we will see that finding one can get another, then get another, and then get another, and maybe even complete a whole table if this chain effect is functional enough. There can be multiple ways to find a box, especially if you've got more numbers up here. It's not always just one way. It's just this example, I made it so there was only one way. All right, and that is it for the notes to share. Let's go back over to the guided worksheet. So using ratio tables, page 65. Here we go. Guided activity 1. This is a ratio or proportion table. it's actually got a similar theme to that kind of original US versus Mexico birthing rate population problem. So they say the number of US births in 2017 was 3.8 million. Is this a lot of births? To make sense of this statistic, we can make comparisons to the US population of 324 million people in 2017, and then compute the birth rate per 1,000 people. This is the third or fourth time I'm reminding you of this. The word per means the next thing is the bottom of a fraction. So given a fertility rate of 60.2 births per 1,000 women aged 15 to 44, so they're saying that this is the general childbearing age. Yes, we are all aware that childbearing age can be younger and older than this. They're just saying on average. So they're only, for one of these statistics, they're only looking at the women aged 15 to 44. But they tell us that there's a fertility rate of 60.2 births per 1,000 women. Rates are ratios. We'll be studying them more explicitly in later sections. But what we can do is work backwards and actually compute the number of childbearing women, just given this information and the fact that all these things are proportional values. So what they do initially is they organize everything in a table. So we have a column for births based on the total population, based on only a population of 1,000 people. So this is us scaling the population down to 1,000. This is a very common theme. I talked about earlier scaling something to 1. This is the same idea, except instead of writing the number 1, you write the number 1,000. So we know there was 3.8 million births for the total population of 324 and some change million people. What we will want to find out ultimately after a little bit is how many women of childbearing age were there, how many births were there per 1,000 people of the regular population, and you'll see that there's no letters in this spot or this spot, so they don't actually want us to find those. But it is 60.2 births per 1,000 people. I'm not saying we can't find them, I'm saying they don't want us to find it. Now, before we actually go and do it with those numbers ultimately, let's keep this simpler and let's just do a different problem. So we will come back to that, but for now, let's start with easier numbers to get a feel for the solution technique and see if we can have things make sense to us. So instead of saying it's 3.8 million births for 324 million people in America, we're saying it's 4 births for 500 people in some random population. There's only 500 people in this population, and out of them, there were 4 births that year. So we want to find out how many births there were if we scaled this population to 1,000. And this is where that idea of the common multiplier will come into play. If you double the population, what do you expect the births to do? That's the idea of proportionality. If this population doubles from 500 to 1,000, what do you think would happen to the number of births? So that'll be a massive spoiler when I answer it. We also want to find the number of women that are in childbearing age based on, okay, well, it's 4 births for a population of 500, but it would be 12 births if there were 900 women childbearing age. Now, this proportion table is set up so that we can find both of those blanks with 2 goes. So I'm going to draw up, actually before I annotate, let's zoom in a little. There we go. So I can write cleaner. So the idea is we want to draw a box in such a way that in that box, 3 corners have numbers and 1 of them has a blank. Well, if I drew my box this way, that maybe this is right, maybe this is wrong. Don't draw these boxes around labels. Only the numbers in the table. Never, ever, ever draw the boxes around the labels, births, population, women. I'm not going to draw the box around that. They're labels, not numbers. You can't use them. This box won't work because this is a blank and this is a blank. So 2 blanks, 2 numbers, that would fail. So let's try again. Maybe you want to do it this way. Like I said, I'm going to do it wrong a couple of times because that's what you would do probably. All right, we got a number in a corner. We got a number in a quarter. But this is blank and this is blank. 2 blanks, can't do it. So clear. How could I tackle, because I can do this one or this one first. I don't have a necessary order for this. I can find this first and then the women, or I could find the women and then the births per 1,000. So I'm going to try and tackle the women. My goal is to have this box be a corner, and since it's in the top right, I'm definitely going to have to draw the box like this. Now, if I drew it here, if I finish the box like this, is this right or wrong? One number in a corner, blank, blank, blank. Definitely not it. So clear the screen. What if I did this? I got two numbers in corners, but two blanks. So nope, that's not it. What if I put my box around all of the data? The entire table except for the labels. Number, 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 blank. That's what we need to do. So my red ink, let me squeeze that in over here. And again, I like to do top over bottom, so I'll go 4 over 12 is equal to x over 900. So I'm going to call this an x. Number, 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 variable, perfect. We can cross multiply. So we'll get 4 times 900 is equal to 12 times x. 4 times 9 is 36. That's 3600 equals 12x. We will then divide both sides by 12, which will give us 12 will go into 36 3 times, so that's 300. So 300 is equal to x. So that says there are 300 women of childbearing age out of this total population of 500, thus leading to 4 births that year. So you can say it's 4 births per 500 people, or 4 births per 300 women of childbearing age. So that's one of the blanks. In blue ink, I will do the other one. So I'm going to try and draw a box in such a way that I can find this blank. Let's call this Y. So we're going to call that Y. That's the corner we definitely need to be using. I'm going to draw a couple bad boxes. This would be a bad box because we got, if we do it this way, blank, number, number, blank. 2 blanks is a problem. So let me undo. If you try and do it this way, you'll have blank, number, number, blank. So that's still bad. Can't do it that way. Maybe this way. Remember, don't go over the label sections. Number, 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 blank. Perfect. So that gives us our equation. I can go 4 over y is equal to 500 over 1,000. Cross multiplying, you'll get 4 times 1,000 is equal to 500 times y, which is 4,000 equals 500y. Divide both sides by 500. And basically you're just doing 40 divided by 5, which is 8. So 8 is equal to y. Y being the number of births per 1,000 people if the population doubled. So this was us scaling the population to per 1,000. So if there's 4 births per 500 people, that means there's 8 births per 1,000 people. Notice that this value is double the previous one. The 500 doubled to 1,000, the 4 doubled to 8. That right there is the ultimate concept of two things being proportional. If one thing doubles, the other must double. You will hear me say this again. I will officially write it in the notes next class. But that's the idea. The idea of two things being proportional means that if you were to double one, the other doubles. You could extend that. You could say if one triples, the other triples. If one halves, the other halves. But it means that there's a constant multiplier between them. So if one of them goes up 10 times, the other goes up 10 times its value. So if something went from 10 to 100, then the other would go from, say, 50 to 500. That's what it means to be proportional. Not only do they increase together, it means if one doubles, the other doubles. Okay. I'm thinking we'll call it a day there. So we haven't finished this section. What we'll do next time is go and complete that original problem, but instead of having nice, easy, pretty numbers like 4, 12, 500, 1,000, and 900, we're going to go back to having numbers of 3.8, blah, 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 million, 324, blah, 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 million, 60.2 births per 1,000 of women of birthing age, scaling the population to 1,000. Once again, scaling a population to 1,000 is a pretty common tactic. You might say, why not 100? 100 is great as well. When we scale things to 100, we just tend to think of them like a percentage. We like to scale things to a 1,000 because then we can knock out basically a collection, a comma collection. We can turn numbers that were in millions to thousands, or numbers that were in billions to millions, or numbers in trillions to billions. It doesn't affect how we say the number nearly as much. But we'll see all of these things. We'll see scaling to 1, we'll see scaling to 100, we'll see scaling to 1,000. Those are the 3 most common that we see in the real world, as well as this course. It's not to say you can't scale it to some random number like 17 or 38.7. It's kind of weird and wacky to do so, but you could.
So we're going to go ahead and call it there. Like I said, we will pick up next time on Tuesday with 2.1 where we left off with that guided activity with the weirder numbers, with the crazier numbers. It feels like a good breaking point. I know we have a few minutes left, but I don't think that we would be able to, well, I'm sorry, I know we would not be able to get that problem completed in that time. So again, we'll call it there. Just keeping the whiteboard up for another minute to remind you of what you are responsible for. Number 3, my math lab homework's now on the docket. If you finish everything and want to go ahead and start 2.1, go ahead and start 2.1 as well. Make sure you are reading ahead into chapter 2. Make sure that you are trying to make that addition or multiplication table like we talked about, because that's going to be a great setup for success for doing that 1.8 Excel BMI file when we get to it. Again, it'll be around the corner sooner than later. Make sure you have that chapter 0 file submitted today, 11:59 p.m. We will not be taking any late work for that, per usual. Excel 1.1 heart rate is due on the 8th. Go ahead and start those attempts. Please, 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 please do not wait until the day something is due to start it, especially the Excel homework. That is a recipe for disaster in a lot of people's lives. Start these Excel files when I tell you about them. Get an idea of what it is. Remember, there are 2 different sets of instructions that parallel each other, and occasionally the instructions that are on the workbook part will be not as specific as the instructions on the instructions tab, and that can end up causing you to lose a couple points, which is one of the reasons I give you 5 attempts. So if you've lost some points, maybe that was something that happened if it wasn't you just typing something wrong or setting up a chart wrong or whatever it might have been. And again, another reason why we give you those multiple attempts, because it could just be an instruction issue, it could be a user issue. There are lots of little things. Remember that you were supposed to be using the downloadable version of Excel. If you are using Excel inside of Chrome or Internet Explorer or a web browser, it is not going to give you full credit on many things. I've already had 1 or 2 students kind of email me and say, hey, what's going on with this? And it turned out that they were using not the downloadable version. They were using it through a web browser. Sorry if you can hear my dog snorting in the background. Oh boy. And then discussion boards, we got 2, one of them due on the 8th, one of them due on the 10th. We talked about the one for the 10th today. And remember, you are only to answer 1 thing per discussion board, please and thank you. Make sure everybody gets a chance. Besides that, if you have any questions, please, please, please shoot me an email. Have a great weekend, work hard, study hard, stay on top of things. We will see you on Tuesday ready to pick up in 2.1. Take care, everybody.